Okay, so then we have to talk about those. So these general processes, these forces that move fluids in and out of a blood vessel, this is called filtration and reabsorption. So again, filtration is going from the inside out, and reabsorption is going from the outside in. And these have to balance each other out in order to make sure that you don't lose too much fluid to the surrounding tissues or vice versa. Now again, filtration going from the inside out, and then we have filtration dropping off from arterial to venule side. Again, remember your blood pressure and your heart is generating most of that blood pressure. So because again, the further you get away from the heart, the less pressure you have. And you have reabsorption, and again, this stays relatively constant because why? Those proteins that contribute to this reabsorption, they don't get forced out into the surrounding interstitial fluid. So this is why reabsorption and BCOP stays relatively constant from the arterial side to the venule side. Okay, so now let's put the two together. So this is why I should start off one at a time. So capillary hydrostatic pressure, again, strongest on the arterial side because it's closer to the heart. Blood pressure drops off as you go from arteries to veins. So CHP drops off as you go from artery to vein. Now with blood colloid osmotic pressure, remember these plasma proteins, they stay in relatively constant concentrations from the artery to the vein side because they don't filter out of your blood. So again, remember BCOP and this oncotic pressure is going to draw water and fluids from the outside towards the inside. So what you have here is kind of like a tug of war, like a pushing or wrestling match. Which side is going to win out? Well, the side with more force, the side with more pressure, right? So let's look at the arterial side. Which arrows are bigger, the CHP or the BCOP? Or which are in this image right here? Which arrows are bigger, the purple ones or the yellow ones? Who's going to win out? Purple or yellow? Yeah, so CHP, the purple ones, are going to win out. So this is why on the arterial side, you're going to have more pressure from the inside, forcing water out. So you get more water being filtered out from the arterial side. So this is what we have here. We have filtration. Now in this image, the yellow and purple are about the same. So when these two forces are matched and evenly matched in terms of pressure, when CHP is roughly equal to BCOP, well, the forces are balanced. There's no movement. Now, does that mean there's no movement whatsoever? It's kind of like having, or if you've ever played dodgeball, or and then you have people throwing balls on like across from both sides. Well, what if the teams are evenly matched? Well, you still have the balls being thrown at each other from both sides, but if the teams are pretty matched evenly, then you should have like no real change in the amount of balls. It should be relatively balanced. It won't. So this is what's happening here. So you have water still moving back and forth, but in terms of overall, if you look at the score at the end, it's going to have neither side is going to win out. Now over here on the venule side, which has the bigger arrows, the yellow or the purple? Who's going to win out, the blood colloid osmotic pressure or the capillary hydrostatic pressure? And there's a question, CHP is higher than BCOP in the arterial side, so there's more water being forced out. Yes, that's correct, on the arterial side. Yeah, so what we see here is that this yellow, because it is now that capillary hydrostatic pressure has dropped off, now the BCOP is going to take over. So the protein in the blood is going to move the water back in. So now we have more reabsorption of water at the venule side. And if you're mathematically inclined, if you like graphs, I mean physiology is full of graphs, this is what we see. Again, capillary hydrostatic pressure is going to drop off because again, as you go from your heart and then from the arteries to the vein side, your blood pressure drops off. So does capillary hydrostatic pressure. So, but again, BCOP stays relatively the same because you don't have filtration of those proteins. Those proteins are pretty constant in concentration from arterial side to venule side. So that's what we have here. This is why we have filtration and movement of water from the inside out on the arterial side, because why? Hydrostatic pressure is winning over oncotic pressure. And over here on the venial side, hydrostatic pressure has now dipped below oncotic pressure. So therefore, oncotic pressure is going to reabsorb water on the venial side. But when you're right here, smack dab in the middle, when they're relatively balanced, you still have movement, but you're not actually going to have actually overall movement of water. Like if you look over time, the volume should stay relatively the same. What is the middle circle called? So it's not really called anything. I'm just showing you something. There's a point where hydrostatic pressure equals oncotic pressure. So I'm showing you an example like, okay, where the two forces are roughly meeting. So they're not exactly going to be in the middle of a capillary. It's just representing the point where hydrostatic pressure, CHP, is equal to BCOP.